All right, my bad. My bad, everyone. I got back from the gym super late. I was not paying attention and I had to rush and get some food. And then I had to rush and get some water. But hopefully, everyone's doing well tonight. Is the music playing? Okay, just went to the next song. How's everyone doing tonight? Welcome. Welcome to another episode of Mastermind Academy. Welcome to the fifth week, I think, of the Python Bootcamp. We're getting there. We're almost halfway through. So welcome. Let's see here. Let me get all set up. Sound good? I didn't get to do a pre-sound check. How does the audio sound? Should be good. I don't change it at all. So, but I do like to test it beforehand just to make sure everything's good. So hopefully that's running right. Let's get this turned up a little bit brighter over here. Facebook. How was a couple people were on the other night rooting for the Chiefs. Hopefully you're excited. I mean, hopefully you're happy. Anyone who's rooting for the 49ers, they put up a valiant effort. That was a really good game. That was a good Super Bowl. Haven't seen an interesting Super Bowl like that in a while, or at least one that I cared about. So hopefully everyone enjoyed that. I had a good time with, like I said, it was my brother's birthday. So I had a good time just kind of chilling with him and a bunch of his friends that he's older than me. He's like 6 years older than me. So I grew up with a bunch of his friends. So it's cool just sitting around, hanging out. We're all getting old. So that was kind of fun. Okay, so tonight, man, we're getting into the really, really fun stuff. We did some algorithms last week, and that was cool. But this week, we're going to be doing some loops. So we're going to be able to add a few more tools to things we can use to solve algorithms. So I wanted to get everyone introduced to them. We did very specific algorithms to not involve some of the upcoming topics that we have. But now we have some loops. So tonight is loop to loops. I don't know where this extra Y came from. I will fix that. So we'll do those. We'll also, this week, we're also going to be working with version control. So we're going to do a whole session on Git and get some coding challenges done. So a little bit more algorithms, even though algorithms part 2 isn't until February 12th. We're going to go ahead and do this. Yes, Nikito. I put this course together myself. This one is based off of a few different things. The DevOps one is based off of the roadmap.sh stuff. This is based off of a few different things. There's Learn Python the Hard Way. There's the Python Bible, a few other things. This is based off of that, off of those. I took some of the flow, some of the things that I liked, switched it up just a little bit, to make it not repetitive, and like not spend too much time on one topic, break things up a bit. So I don't know, this is the first time we're running through the Python one. We haven't done any full coding ones. We've only actually done one bootcamp ever, and that was DevOps. So we're learning a lot from this one. We're going to do a whole retrospective on all this at the end. So take notes and see if there's anything you found weird about the pacing, weird about the order. And definitely when we get to this March 25th date, definitely share that so we can, next time we can modify the course accordingly and make sure everyone can get, we can turn this into the best course that it can be. But cool, tonight's loops, and later on we have Git this week. So awesome, this should be some pretty fun stuff. What time is it? 8:06. We'll give people 4 more minutes to get all in, get settled, grab some food, grab some water, relax, sit back, kick off your shoes. I'm about to kick off my shoes. Mine. I came from the gym and just took a shower, so my feet smell great. Don't sweat that. Don't worry about that. But yeah, just relax. We're gonna have a little bit of fun tonight. Tonight should be pretty chill. We've been getting through all the Python stuff. I love the Python course. I mean, I love the DevOps one too as well. But the Python course, we can get through the stuff in 2 hours, which is super nice. And I like that, especially because I have a lot to do this week for things related to Mastermind, but for the incubator that I'm in, that Hutch incubator that I'm in, there's a lot of work to do for that on Friday night, and so just trying to get through that stuff. All right, let's hop into the slides. You all should have the link. This is the wrong account. Get in here. Let's clean some stuff up real quick. Let's go there, get our slides open. Actually, back. Oh, it's right there. You should go on the drive. I just shared it, so it should be the newest one. All right, slides open. Let's go down. Let's get a terminal open so that we can have our terminal ready, and that should be all we need. Just two things. And present. Let me make sure all of my monitors and stuff are up so I know how the stream's doing, and making sure that I'm not dropping frames. The stream, it's been doing really good, like hardware performance wise, ever since I got the Ethernet. So those drop frames that I was getting a lot of drop frames before, but it was definitely because of the Wi-Fi. That's been pretty cool. Anyone who's in, nope, we'll talk about that later. Cool. All right, 8:08. I told everyone 8:10, so if people left and went to the bathroom, I'll allow it. Give you a little bit of time. How's everyone's Monday? My Monday was very interesting. It was a lot of work, as usual. You walk into a new week, got to get some stuff done. We're at the end of a sprint, so we do our work in 2-week chunks, basically 2-week cycles. So every Wednesday we basically get assigned new work. We pick out new work. We do it for 2 weeks, so we do it from Wednesday until through the next Wednesday, until 2 Wednesdays from there, or till the next Tuesday. And we finish up by then, and we start over every Wednesday. So we're at the end. So our sprint ends tomorrow. So we're just kind of wrapping up some stuff. We're building out a pretty large piece of architecture. In comparison to the system, it's not the pieces itself aren't that big, but it is a large part of the system that we're building out. So it's been very interesting. We have a pretty quick turnaround, and when it's due, it's been pretty interesting. But then I had to deal with some drama, some other stuff, which was interesting, but I don't know, it's cool. I'm learning a lot about running a business, so that was exciting. I learned something today, something I didn't want to deal with. It's actually why I was at the gym for so late, because I got to the gym pretty late because of it. Okay, 8:10. Let's get going. Let's talk about loops. Loop de loop, end at the beginning. So luckily, we've already been introduced to loops in the first algorithms course very lightly. This is your formal introduction to loops and what loops are. Loops are very important. You'll use loops all the time. They are one of the best tools in programming to solve problems. Okay, what in fact is a loop? A loop is used to run a set of instructions multiple times. Hey, Crazy Rim, thank you for the follow. Welcome to the channel. But it's used to run a set of instructions multiple times. So instead of having to type the code more than once, you can use a loop to run a set of instructions multiple times, more than once. There are different types of loops. So every language, not every language, but different languages have different types of loops. Most of them have at least a for loop. That's kind of standard in just about every language. Python has a for loop and a while loop. For most languages, anything that has like a while loop, it's actually what's called syntactic sugar for a for loop. So for most languages, underneath the while loop, we're going to talk about what a while loop is. It's actually basically a for loop underneath, but it's written to help you be able to do things a little bit easier. It's not the case in Python, but we are going to talk about that. But we have the for loop and the while loop in Python, and we can use them in different ways for different things. And we're going to learn exactly what those use cases are tonight. And it is important to know that loops run for as long as a scenario you specify is true. So in our previous streams, we've learned how to set up scenarios. We learned how to use comparison operators to kind of determine whether or not something is true. We basically test a Boolean value, and if it is true, loops will run. If it is not true, loops will not run, or they will stop. So that's a general overview of what that is. So let's hop into the first loop, and then we'll hop right into some code and get this done. And actually, I should have included one more thing in these slides, but it's fine. We'll talk about it. Maybe we'll add it. So while loops, a while loop. While loops execute code for as long as a scenario you specify is true. That is true of all loops. It's true of all loops. It's a little more true in the while loop instance. When you're trying to understand it, it's a little more true in while loop standards. A while loop can create infinite loops, so you can actually create infinite loops no matter what. But while loops are very easy to create infinite loops. They're commonly used paradigm to create something that loops an infinite amount of times, and there are ways to manage that. Once the loop is running, it doesn't just go forever, or it does if you do not take action, but you can take action to make sure that that doesn't happen. And you can use the continue and break keywords to give you additional control of while loops. There's one more in there. I think there's pass. I think they have pass in Python. I don't know. I'll check that. But continue and break are two we're going to hit first, and we're going to talk about to give you additional controls. And let's talk about what they do. Let's talk about while loops and how to use when to use them first. So while loops are best used when you aren't sure how many iterations of the loop need to take place. You can, again, these two loops are pretty interchangeable, to be honest. There are better used in certain scenarios. This is the best scenario to use a while loop in when you are not sure how many times you're going to need to repeat this code or re-execute this code. But again, we can, even when we know how many, in the very first example we're going to do is counting to 100, we'll know exactly how many times we need to do it, but we can use a while loop to do even that. So let's hop into let's make a file really quick. So let's go into our trusty mastermind Python folder. I always forget streams, Python, and we're gonna make a loops folder. All right, so we got this loops folder. Let's go while.py. Wow, I did not do anything. We're gonna open up this, we opened up a new file. We opened up a file.py, nameless slug 0. It should be up a little bit. Here, let me give you, let me copy and paste it in again. Or the slides. That's a good thing. I should automate the slides command, because I can grab, all the slides are done, so I can grab them all and do a little Python script or something to update them daily. That'd be pretty cool. Okay, we got our file open. Let's write a basic while loop. So what does a while loop look like? Its anatomy is like this. You type while. So while is the keyword that starts it off. And so you do, oops, let's make it a little bit bigger. You do while, and you can see it turns red. I don't know why saying the word while over and over again and then typing it looks wrong and it sounds wrong, which is super weird. But just like other things, just like an if statement, we are gonna say while this statement is true. So this is not the syntax. This is not the syntax at all. But this is how it works. So we're gonna say while whatever's here is gonna evaluate this to be true or false. As long as this is true, a while loop will run. So we can say something like while x is equal to 10. While x is equal to 10, let's say print x is equal to 10. X is equal to 10. I haven't written in Python this week. It feels weird. It's like I need to stretch or something to be able to write some Python. So now this is not going to run. This is not going to run at all because I'm evaluating the statement. We actually don't have x here at all. But this is just, again, I wanted you to see the syntax first. While x, like you say, while specify a statement you want to evaluate. So you could say while x is greater than 10 or less than or greater than equal to. You could use those operators to combine them using the and or operator. And again, it's going to evaluate to a Boolean value, which is true or false. And then it's do something. So basically, this is basically an if statement. You've seen if statements. You know, you can kind of, hopefully you know what this looks like now. So we can actually just run this just to see what happens. And it's not gonna work. No biggie. Oh, why is it not gonna work? Actually, let's look at that. This is fun. Invalid syntax. It gives us an invalid syntax on x equals 10. Remember, think about the things that you have to specify. Think about the things that you have to do. This, what's up, Bear Guns? Welcome to the channel. Thank you for the follow. What kind of operator is a single equal sign? A single equal sign is an assignment operator. So what's actually happening here is it's trying to assign the value of 10 to x, but it can't do that in this place because it doesn't make any sense. If we actually wanted to check equality, we would need two equal signs. So very fun. Yes, we do need to define the variable, but let's see what happens when we don't. What happens when we don't define the variable? It lets us know that it's not defined. There are languages that will try to do this, even though you didn't define the variable. So let's go ahead and define this. And we can say x equals, let's set it to 5 first. X equals 5, and we say while x is equal to 10, go ahead and print x is equal to 10. And let's run that, and it kicks us right back out to the prompt. Again, this is just to show that this statement, the statement that it's going to evaluate, is if it's not true, this evaluates to false because x is not equal to 10. So this is a false statement. This never runs. But if we go ahead and change this to 10, and we run this, and look at that. You can't tell that it's still running, but it is still running. It is printing out a crazy number of times. You can see a little blip at the bottom. Every so often, I'm gonna hit Control C and end it. And I can't even scroll to the top because it's printing out so many times. Why is it doing that? It's doing that because, again, while loops, remember we said up top that while loops can create infinite loops. So you can create a scenario with a while loop that creates an infinite loop. So we said while true, do this thing. So it goes through, it evaluates, it runs this bit of code. It goes back up, it says, hey, is x still equal to 10? Yup, prints this out. Goes back around, says, is x still equal to 10? Yup, print it out. And so that's why we get an infinite number of printouts. This is how you create a loop that is never ending. You can do this in a couple of different ways. Actually, you can also just do something like this. Even if we never specified this, we could simply say, while true. So again, that statement there needed to evaluate to true. We could also just set it to true, and then this will always print. So this should run. And there it goes. It's going ahead and it's printing everything out because we can use true. So you'll commonly see it this way. You'll commonly see it set up this like. You can use this paradigm a lot. Again, if you don't know how many iterations you want to do, you'll say, while true, go ahead and do this thing. And you'll do some calculations. You'll do some modification of data. And when you want to have it no longer run, you will change. You can either break out of it. You can break out of it. Oh yeah, let's do while false. I like this. See, I like different examples. Seeing it live is better. So what happens if I do while false? Do while false. It never runs because, again, loops, if statements, they have to evaluate to true for them to do anything. So while false does not work, it never runs because it has to evaluate to true. So what happens if you want to break out of this? What did I say up here? Continue and break are keywords you can use to get out of these loops. So if I wanted to run this, if I ever wanted to get out of this, I could run break. Do I have to put this afterwards? I can't remember. Let's just do break. See what happens. I put the break keyword there. It runs a single time and then it exits. So then it breaks out of the loop. So this is one of the ways, this is one of the keywords you can use to control the flow of the loop. I can run this. I may want to run it a bunch of times. So maybe you want to do something like this. We know, let's build something out real quick. So maybe we want to check when x is equal to 10. So let's say x is 0 at first. X is 0, and we want to count up until x equals 10, and we want this to stop once x equals 10. We want to know when it's 10. We want it to exit when x equals to 10. So we're gonna say x is equal to 0, and we're gonna say while true, print x is equal to 10. We're gonna say while true. This is a dumb way to do it because you would just do this. Well, no, let's just do this. This is a dumb scenario. You would not handle it this way, but you could do while true, and you can put an if statement in here. So in these while loops, you can still do all the same stuff. The code that runs when a loop executes, it's the normal code that you know about. You can run any of that stuff. So we're gonna say if x equals 10, then we're gonna go and print out this. It's again a dumb scenario. This is not the best way to do this, but it's a fun way to do it. And then we're gonna say if x equals 10, go ahead and break out of this. So what we're also gonna do is we're gonna add 1 x plus equals 1. So then we're going to add 1 every time to this so that this will actually count up, because we would actually create an infinite loop. We've seen ourselves create an infinite loop before, but this time this is true. It'll say if x is equal to 10, go ahead and print this out. So when x is 0, it should not print this. It should fall through and it should run x plus equals 1. And now x will be 1. And it should go through and it should count all the way up to 10. And then we should be able to print that out. So let's see if that works for us. And we get a single printout. We got that before, but how do we know? How can we check to see that this loop actually ran and like that it's actually doing something? Let's go ahead and print x. Like if we want to know what's happening, if we want to see what happens every iteration, let's go ahead and let's print out that x. So the first thing that's going to happen is this is true. It's going to evaluate this. It's going to say while true. So this is true. It says print x, then evaluate this statement, then add 1 to x. So let's go ahead and do that. And if we run it, we can see the numbers here. So we know that it's iterating through each time, and it's adding 1 to x every single time. And when it gets to 10, it says, hey, x is equal to 10, and then it breaks out of that loop. So that break keyword, no matter where you put it in here, this will break out of that while loop. So you have to be careful where you put it if you have multiple loops. But that break keyword is used to control what happens, again, when you get into these infinite loops, when you create these scenarios where it's looping through an unknown number of times, you can exit when you need to exit. So that is what break does. And that's really important to remember. So continue is the other keyword. Let's talk about what continue does. What's a good scenario for continue? If it's just one big infinite loop until it breaks, that's a valid, deep statement. It's deeper than I am, but it's a very deep statement, and I like it. I'm going to use that as a quote one day. All right, so continue. Let's say, all right, let's say once this loop is, let's say we don't want this to print out when this is 10. Yeah. Let's do this. Let's take this line here. Also, a very dumb scenario. So let's say we're going to undo. Make it double X if it's even and stop once it's greater than 50. Okay, let's do that. Very interesting. So we're going to infinitely, okay, no, we're not doing infinitely nested infinite loops to create new loops and break others. So we're gonna make so we're gonna double X. I like this. Double X if it is even, and stop once it is greater than 50. But I'm not sure. Let's just do that. Now, do you want me to do this the best way, or do you want me to do this the jankiest way? The big range solution is implementing multiplication, summation loop using. Sure, we're doing the smallest range solutions right now until we can get to the big range stuff. Okay, let's read this. We're gonna say double X if it is even and stop once it is greater than 50. I'm not sure this is gonna be a good use for continue, but let's see. So we can say while X is less than or equal to 50. So this sets the parameters. We want to run something as long as X is less than 50. We want to stop once it's greater than 50. So we want to run this for as long as it's less than 50. And we want to double X times equals 2. And we'll go ahead and we will print it. Well, this is actually going to fail because X is 0. We're going to make X 1. But let's go ahead and print X. Now, this would fail. I think this will satisfy what was put in the chat by Nikito. Or was this? Yeah, this was Nick Ito. Is it Nikito or is it Nick Ito or is it Nikki 2 or is it? Spell it phonetically in the chat. All right, so let's just see what's gonna happen. Oh, just Nick. Interesting. I got all of the wrong answers until you gave me the right one. So what's up, Nick? Okay. So very simple. This is actually gonna fail. So what are we actually doing here? The goal we wanted to do is actually double X if it is even and stop once it is greater than 50. So what we did here is we said, hey, as long as X is less than or equal to 50, go ahead and run this loop because again, as long as it's over 50, once we get greater than 50, when it goes to evaluate this, if X is now 51, it says, hey, is 51 less than or equal to 50? It says nope, it will not run our loop. But what we want to do is we want to double our number. We can't use 0 here. Let's go ahead and use 1. We can add some other logic to like add 1 if it is 0. What we can do is we can print out X and we can say X plus equals X. So we want to double it. So we want to add X to itself. So if the number is 1, we want to go ahead and add 1 to it to make it 2. And if X is 2, we want to add 2 to it to make it 4. And if it's 4, we want to add 4 to it to make it 4. So we add X, and then it runs. So let's print X afterwards and not beforehand. Cool. So let's go ahead and let's print that out. Oops, X is not defined. Oh, look at this sweet capital X. That makes sense. Capital X is not the same as lowercase x. But we'll go and run that when X is 1. Look at that. It prints out every time until it's greater than 50. So why? Let's I want you to think about oh, you said if it's even. I didn't even check that. You're right. I never even read. See, this is why reading is fundamental. Remember when I told you when you're working with algorithms, first thing you need to do is understand. I completely ignored this. And I completely ignored this. So yes, gotcha. We need to do more work here. I missed that completely. So we learned how to check if something is even. When did we learn that? We learned that when we did FizzBuzz. We learned that during the modulo section. We learned that last week during some of the algorithms. Let's check if the number is even. So we're gonna say X plus X equals X plus X. So we're gonna double X first. And then we're gonna say if X, if it is even, double X only if it is even. Okay. So no, we don't want to double X off the rip. We want to check if it's even. So we're gonna say if X modulo 2, so anything divided by 2 is an even number. So we can check if it's equal to 0. Because again, let's talk about modulo again. What's up, Krabby Goat? I love the name. Thank you for the follow. Welcome to the channel. So if X modulo 2 is equal to 0, that means the remainder that was returned was 0, and that means a 0 remainder for modulus means that it is even. It's an evenly divisible number. So we're gonna check if the number is even, and if the number is even, we're gonna double it, and we're gonna print it out every time. Okay, I got you. So let's see what happens when we do this. So let's make x 1, and we're gonna say while it's less than 50, if it's even, go ahead and double it, or else print it out. So let's check that out first. And we get an infinite loop here. So let's actually break this down and see why we got an infinite loop. So actually, I really like these scenarios, and I like working up to the scenarios that you guys are giving because the logic of so many times you'll have to troubleshoot why a loop is doing something unintended, or the logic of a loop can throw a lot of things off, especially if a lot of things are happening inside of that loop. So let's take a look at this loop and figure out why it did nothing but print out 1 an infinite number of times. We got stuck in an infinite loop that I had to kill where we're just printing the number 1. Let's walk through the logic here. So x equals 1, we set that up here. We want to double x if it is even and stop once it is greater than 50. So we set up our scenario here to stop once it's greater than 50 by checking to make sure that it's less than 50, less than or equal to 50 before it runs. Now, if x is 1, it says 1, it does 1 modulo 2. Is that equal to 0? It is not equal to 0. This will not return to 0. So it does not run this bit of code, and it goes ahead and it prints out x. So first time it does that, it prints out 1 because x is 1. X is still 1. It says, is 1 less than or equal to 50? Yep, 1 is in fact less than or equal to 50. And then it does it again. It says, is 1 modulus 2 equal to 0? No, it is not. So is 1 divided by 2? Is there no remainder on that? No, there is a remainder on that. Very interesting thing. And it doesn't do this because, again, this has to be true, and it prints x again, so it's 1. So we get into that infinite loop again, and this is, again, a very common thing, and this is why we called it out. Why we called it out here. Whiles can create infinite loops, because I've seen people run a program where the infinite loop doesn't have an output, and they think the program is processing, and it's just stuck. So it is processing, it's stuck. Because there was no output, they didn't know that it was like an infinite loop, and they were sitting waiting, thinking the program was gonna be good, and it was not. So I want you to just take a look at it. Hopefully you understand that piece of it. See if in your mind you can figure out how we're gonna fix this, and we're gonna fix it up in a second. So he said if 2 modulo 2 continue. We can add it after. Okay. So I like that. Let's implement the Ackermann function. Maybe we can do that. I've seen the Ackermann function before. Yeah, that looks. I don't want to teach math, and actually, I don't want it. This looks. Maybe I don't know what the Ackermann function is. The simplest and earliest discovered examples of total computable function that is not primitive. There's too many words in this, and we're not doing this tonight. This may be cool though. I'll check it out. I remember when I was first learning Python, and actually when I first started doing Project Euler or Project Euler stuff. It seemed so hard because every time I went to go look for how to do the math, I would get these giant Wikipedia pages that like had a bunch of symbols that I didn't remember because I didn't like math. But then they were actually really easy once I watched a YouTube video on it. Interesting. All right, why didn't that continue really quick? We can add it after, that makes sense. I guess it makes more sense to make it if it's not even, otherwise it would always multiply. If it's done once, check before because the initial number is odd. Oh, yep. The initial number will need to be even. Pass the first condition, but fail the second. I like how you teach people how to debug. There's so much emphasis on training how to. I agree. I appreciate that you appreciate it. I do agree that everyone tries to teach you how to do things right, but most of my day is spent figuring out what's wrong. To be 100% honest, yeah. Else print. Please enter an even number. Makes sense. We could do that. Sure, termination is a nice quirk feature. Many loop mechanisms in languages. Yes, that is very true. TLDR, that's funny. Wikipedia math pages are famously bad. They are famously bad. can you debug and step through with your Vim setup? Like, do you mean like attach a debugger? I do not have, you can attach debuggers to your Vim setup. There are debuggers that are available. Mine is not set up to do that. That would be cool. That would be really cool to do. I'll actually take that on as a challenge to see if I can get a debugger set up in Vim, or we can just do it in VS Code one day. Maybe when we start getting into, that's a good idea. When we get to the heavier algorithm sections, we'll use VS Code to attach a debugger to these things and step through the logic. Debuggers are really nice once you learn how to use them properly and effectively to help you solve some problems. I thought they were dumb at first, but they're better than putting in print statements and trying to debug that way. So we will do that. Yeah, I agree. Watching in real time is part of the fun of it. Can you remove the increment from the if statement block? Yes, I can. I can remove the increment from the if statement block. So let's do that. So we got, actually, yeah, let's solve this. I'm interested. So if I remove this from the if statement block, and I put it out of the block, I didn't even need to do that. So if you guys remember, Python is white space. What am I doing? Escape. Oh, okay. Wow, I'm struggling. Python is white space matters. So I can leave this on whatever line I want, but as long as it is outdented, as long as it's on the same line as the if statement, it will it is no longer nested underneath the if statement and will process it accordingly. So if I go ahead and I move that out, I can do that. So Afrocoder, I did that here, and so we can see what happens. Let's look and see what happens when that happens. Interact. All right, so we have someone saying it would loop forever because X never changes, but I don't know if that's true. So let's run this. I think this is interesting. So we have a while loop here, and again, I'm gonna keep going over what it does just to try to drive home what it does. It says X less than or equal to 50. So it's gonna check if X is less than or equal to 50. If X is less than or equal to 50, it's gonna go ahead and it's gonna run the code below it. Once X is no longer, whenever this runs and X is no longer less than or equal to 50, it will stop running everything underneath it. So if X is less than 50, go ahead and run this. We know X is 1, it will run this code. So it'll check this. It'll say, is 1 modulo 2 0? It is not. So any code under here would not execute. So there's no code under there, so we shouldn't see anything. Now, again, this code is not under here because it's nested. It's not nested underneath. It's on the same level. White space matters in Python, and so then it will take X and it will add X to it, so it will double and it will print X. So let's take a look at what happens when we have this. And I'm gonna go down the list. I'm seeing your I'm seeing everyone's things we want to try. So I'm gonna go through that. So expected an indent block. So it actually, that's interesting. I actually would have expected it to do nothing. So maybe we can use the continue block here. Yeah, maybe this is good. Okay, yes, this is a good use of, now I see, this is a good use of the continue block, a very good use of the continue block, actually. Not a good use, but to show you what's gonna happen. So what does continue do? First, let's talk about what continue does. I was trying to think of a good example before I told you what it does, but this is actually gonna be very fun. So I don't have any statements for the ifs, but the continue is now a statement for the if. Continue says, go ahead and instead of breaking, it's kind of like a break in that you've hit this point, and I want you to now exit the loop, but I want you to exit only this iteration of the loop. So exit this iteration and go ahead and run the next iteration of the loop. So if you ever get to continue, it will break the current iteration. It'll stop the current run through and it will start the loop back over to iterate again. So let's watch this really quick. So it's going to check if the number is even. If it's even, it's going to continue. And so this is, yeah, we'll just run this. And again, talk through the output. All the outputs are going to be random crap that's not like, doesn't make a lot of sense. But Yeah. Okay. So it prints something and it never really, it hasn't kicked us back to the prompt. It's actually still running. So the code is still running. We are stuck in another infinite loop. How did we get in the infinite loop this time? And why did it print out 2? Why in the world did it print out the number 2 and then give us an infinite loop? Whoops, I ran again when I wanted to look at it. All right, so let's talk about what happened. It checked if 1 modulo 2 was 0, which it is not. So it did not run this continue. It flipped through to this block here. What does this block do? This block goes ahead and it doubles X. So it took 1 and it added 1 to 1, and then it printed that out. So that's where we got the 2 from. So 1 plus 1 equals 1. It printed out 2 because X is now 2. This is both an arithmetic operator and an assignment operator. So it adds what's on the right to the variable that's on the left, and then it assigns that value back to the variable. That is the cool thing about plus equals or minus equals or multiplication equals. Really cool. And it printed that out. So we did get the 2. But then while X is 2, so it says it's 2 less than or equal to 50. Yep, it is. Now it's 2 divided by 2. Does it equal 0? Yes, it does. So this is now a true statement. It's 2 modulo. 2 divided by 2 does not equal 0. It equals 1. But 2 modulo 2 is equal to 0. And then it hits this continue statement. So it says, all right, I'm not going to do any of this stuff here. I'm going to end this right here. And I'm going to go to the next iteration. So X is still equal to 2. And it runs again, and it says, yep, this is good. And it says, all right, continue. And it goes again, and it just keeps going. So we get stuck in this infinite loop that never actually prints anything out. It never gets down to these print statements because we get stuck here where it restarts the iteration. So that is the big difference between continue and break, which is cool. So we can use this to say, let's do it beforehand. We can do it beforehand. There's a bunch of ways we can solve this. Actually, let me go through and see the options you all have given me so far. There's a lot, so I'm sorry if I miss yours. Loops wherever X number changes. If you have a theme, is it white space? That's a good one. That's a good shower thought. You should put that on Reddit, our shower thoughts. That's a good one. I don't know what this color is. It's not black space. It's maybe it is. Maybe my screen is, maybe it's dark brown space. I don't know. That's very interesting. Maybe it's not empty space, empty text space maybe. But cool. So if you put the X plus equals X line back in, this is here. Do you say put this in, are you saying put this in the if statement? I think you're saying put this in the if statement. So I'm going to go ahead and I'm going to do that. I'm going to go ahead and put it here. I'm going to put it before this. And let's put this here. So let's just, again, I think that's what you wanted. If not, not a big deal. So now let's see what's going to happen. We're going to say if X modulo 2 equals X, go ahead and double it and then continue without printing it out. So let's see what happens here. Okay, so we got 1. Let's change our number. 1 prints out because again, it's just going to, this is just never going to be true. And it's going to print out X and it's just going to keep going through and it's going to do this. So let's change X to 2 and see what happens. So our starting number is pretty important here. So now X is 2, X is not 1, X is now 2. And when we run X equals 2, when we start with X equals 2, it goes ahead and it doesn't infinitely loop like we may have expected it to do. It pops us right back to the command line. Why does it do that? So the program actually runs and it exits. But why does that exit? So it exits because so when X is 2, this is true. So it goes ahead and runs this. It says is X mod 2 equals 0. Yep. So it takes 2 and it adds 2 to 2. And then it continues. So it goes to the next iteration, never prints it out. Remember, the continue ends it right where continue is at. It ends the iteration, starts the next iteration of the loop. So it does it again. Now it's 4. And is 4 less than 50? Yes, 4 is less than 50. Is 4 divided by 2 equal to 0? 4 modulus 2 equal to 0? Yes, it is. So 4 plus 4 equals 8. Continue. So this is actually working. Even though we never get to this print statement, this is actually working, and it exits. It achieves what it achieves the goal because it runs through, and there's a point where this gets to be above 50, and this drops out. It no longer runs this while loop. Exits the program, and that's great. Why does it do that? It does it because X. Because the print statement is out of here. So let's do this. Let's do this right here. Let's only print out the even numbers. So we're gonna put this print here. We're gonna print out X, and we're gonna start with 1. We're gonna start with X equals 1. And then the first thing we're gonna do in here before we do the if statement is we're gonna increment 1 every time. So X equals X plus 1. So this way we can make sure that X moves up. So actually let's use our same stuff. So we'll do X plus equals 1. So now instead of what we were doing before, it's gonna say if X is 1, go ahead and add 1 to X. So now X is 2. It'll run through, this should be true. It'll double it, it'll print it out. So we should get the very first iteration we should get is 4. Actually, let's do this with 0. Let's start from 0 and just see what happens, and then we'll talk through it. So now X is 0, and pay attention to this continue here, and let's see what happens. We run it out, we only get a few numbers, we get a single number that's larger than 50. Let's check that out. Let's check out what happened here. We get a 4, a 12, a 28, and a 60. And that's all we get. We don't get any other numbers. So we already know, just pay attention to where our print statement is. So we already know that it's only going to print out if it is an even number. So we set this case here, and the only print statement is inside of here. So take a look at what is here. All these numbers are even numbers. So that's good. But why only these numbers? Again, because when X is 0, the first run, it goes ahead and it adds 1 to X. So now X is 1. And then this is not true. This is a false statement. So nothing happens here. It runs again. And now X becomes 2 on this line. And now this does become true. So now as soon as we get to a 2, now we get some faster moving things. So 2, we double 2, and now it's 4. So we print out 4. This runs through again. And X is 4, and it adds 1. So now X is 5. So the run after this, X is 5. This is not true. So 5 never prints. It goes through again. X becomes, X is still 5. X becomes 6. Once X is 6, this is true. So when you double 6, what do you get? You get 12. So it prints out 12. We saw 4, we saw 12. So while X is 12, it runs through again. 12 becomes 13. So this is not true. Goes through, X becomes 14, and this becomes true. You double 14 right here, it becomes 28. So we have 4, 12, 28, and then this becomes 29, which nothing happens here. 30, go through here, double 30, you get 60. So again, you should get 4, 12, 28, 60, and that is what we got here. 4, 12, 28, 60. I won't do that fast. I know that can be confusing. That is the continue for that. Again, if we do let's do this right here. Well, that'll print out everything. Let's put something that runs every time. Let's put it at the end. Put it at the end. Let's put this line at the end instead of the beginning. Let's increment at the end. So now what we're going to do is we're going to do the if statement first, and then we're going to increment rather than incrementing beforehand. So let's see what this output gives us. And we get 0, nonstop. Let's start with 1. Let's start with 1 and not 0. I'll talk about why that in a second. We'll run this, and we get a different set of numbers, but ultimately we get the same thing. We'll get a different set of numbers. Why are the numbers different? So the continue works in the same way. So the first time X is 1, it runs through. This does not fire. This code here does not fire when X is 1, as 1. So now X is 2. When this is 2, it fires. So the first number we now get is 4. So it'll double X, give it 4. It'll continue. And when it continues, it does not add 1. It will not add 1 here. So the next time this runs, X is 4. It'll get sent back through. X 4 is an even number, so it will double again. So it'll go straight to 8. And then this will print, and it'll do it again, and 8 will go straight to 16. It'll print again, 32, and so on. So in this method, you actually, once you get to your first even number, you actually no longer get any odd numbers because of the order operations. Because again, this never fires because the continue breaks out of this loop immediately. So there's never an add 1 to make the even number now an odd number. The continue breaks out of the iteration, starts the iteration over again. So hopefully that was not too complicated. It was a lot. Loops can be super interesting. We're about to go over for loops in a second, but ask any questions that you have about this, or I can add in some more options if anyone said anything. Let me actually get back to the chat. I'm lazy. I just put I instead of continue. Are you tricking me? Are you tricking me? Who's tricking me? I don't like this. Never know when everyone's joking or not. I just put I. No, I don't believe you. Just doesn't mean anything, or maybe it does. Maybe it's something I don't know about. Or is that 1? Can I not see? I just put 1 instead of continue. Is that a thing? Hold on. I think you're fooling. I don't believe you. Stuck on 1. I don't know what y'all talking about. I'm struggling. I don't understand what you're saying in the chat. I told you guys are always trying to trick me. I don't believe you. True also works. I'm confused. Definitely confused. All right, so if you put the print on line 5, you would see the infinite loop. Sure. How do you get WSL in the desktop mode? I have no idea what that means. WSL is the Windows subsystem for Linux. I don't know what desktop mode means for that, to be 100% honest with you. Twitch chat delay is annoying. You put the X back in the response, change it. Yeah. The chat is a little annoying, and I'm sure there's a pretty large delay from when I'm streaming, like what you're seeing. Oh, and else plus equals 1. Yeah. There's a million bajillion fulfillion ways that you can do this, but I'll leave the continue back in. Just wanted you to know what continue is. So again, while loops, again, as long as something is true, while loops will run. You can use them to create infinite loops. Again, you can use just while true, or set a statement that will always be true, to create infinite loops. So be careful of that and use those to your advantage. We'll learn how to do both of those things. And then just knowing that to break out of a loop, if you ever want to end the iterations, you can use the break keyword, or you can use the continue keyword to end the current iteration, basically to break the current iteration and start the next iteration. There's also pass. Pass just says, hey, just go through, like keep going. Pass just says keep going, but we'll see that a little bit later. Cool. So these are loops are very important to solving a lot of the problems that we have. And again, yes, while loops are best used when you don't know how many iterations of something you are going to be going through. But even if you do, you can still use them. So let's say I just wanted to count to 100, and here up top, I said X equals 1. And I can say while X is less than or equal to 100, go ahead and print X for us. And so that did not work. Why did that not work? We got ourselves into an infinite loop again. And that was actually not me trying to prove a point. That was just me brain farting and not doing anything. We want to count to 100, so we need to increment X plus equals 1. So we'll count by 1. And we're basically going to say, as long as X is less than or equal to 100, go ahead and print it out. And then after you print it out, go ahead and add 1 to it, start the loop over again. And it should stop right when it's at 100 because that is the parameters that we set. And we can see here, it counts up to 100. No problem. So again, while loops don't only need to be used when you know the number of iterations, but again, there are easier ways. There are ways that are better to count to 100. There are better ways to count to 100, which we're about to learn. But you can do it I want to say, so you can use for loops for anything. Don't know if you can use while loops for anything, but I think you can. I think you can use while loops for just about anything. I'm trying to think of a scenario where a while loop wouldn't work. Not where it wouldn't be good, but specifically where it wouldn't work. And I cannot think of a place where it wouldn't. But cool, that is while loops, right on time. Cool, now we just have for loops. That was almost a whole hour. We just have for loops, but we can end early. We don't need to spend much time. We're also going to do a problem or two to make sure we've kind of got it. So loops, when to use them. Again, this is when you're not sure how many iterations need to take place. But now let's talk about for loops. For loops are my favorite. Again, you all know, I haven't been shy about Golang being my favorite programming language. For loops are the only loop that exists inside of Golang. So it's actually been a little problematic because I default to using them even when in other languages a different loop would be better. But yeah, for loops are cool. A for loop is a control flow statement for specifying iteration, which allows code to be executed repeatedly. So again, it is a loop. But think of it a little differently as more of a control flow statement when you want to iterate through something. So what I didn't show you, I'm going to show you how to use while loops and for loops to iterate through things other than numbers and counting. We've only seen us use those things for counting. I'm going to show you some other things. I'll show you why indexing is cool as well in a second. But yes, for loops are cool. They're a control flow statement. Think about them as that. Well, I like to think about them as that. So for loops, when to use them. For loops are best used when you know how many iterations of the for loop need to take place. They're also best to use when iterating over an object. You don't know what an object is yet. Not a big deal. We're going to find out in a second. But in terms of this, we're talking about iterating over things like strings or things like lists or dictionaries. Well, maybe not dictionaries, but things like lists. Let's go with lists for now. You can iterate over them. So they're order any data structure. Remember, go back to our data structures course. Anything that's structured data that is ordered can be iterated over. So the things have an indexed spot there. The position matters, and you can use that to be able to iterate over them, to move through them. So we're gonna learn that. We're gonna go over that in a second. But for loops, there are a few ways to set up for loops. There are a few ways to set up for loops, but the for loop in Python is an interesting for loop. It differs a bit from other for loops. For loops have basically a for each function. Basically, I think that's all a for loop is over. I think for loop is over in cases of for each. But let's open up a file really quick. For.py. Okay. And so again, for loops, I'll also teach you a little bit about the function range as well. So, someone got in trouble, Afrocoder. I still have not made Nightbot. It's still on my list. It keeps getting pushed down under other stuff. I'm going to make Nightbot less angry for sure. It'll happen eventually. But there's some more important things that need to take place, like fixing the spelling on the starting soon screen. That is, it's bothering me. I never have time to do it. Maybe I'll try to do it tonight. Trying to post my while loop. I'm sorry. Maybe remove some symbols or something, or I don't know. That's super weird. Okay. First for loop. So again, start a for loop. We can do the for keyword. So let me show you. Let me show you how we can iterate over something. Actually, does this work in Python? I don't know if this works. So you can use the for loop, and you can use the in keyword. For has an in keyword as well. So I can specify something. I can basically say for an item or object that's in a collection of things inside of an object. So for item in object, do something. So I can say something like for letter, and literally this is like a variable here. This is a variable here in word. So I'm gonna make a variable called word. I actually don't know if this works in Python. I don't know if strings are an iterable object. But let's say word equals hello, this is a single word. So we got a string here, and I can use this loop, this for loop, to iterate over the letters that are in word. So for letter in word, print letter. So let's see what happens here. I really don't know if you can do this in Python. I think you can though. Python 3, I never remember what I can and what I can't. Okay, so you cannot do this. Did you mean to, oh yes, never mind. Maybe you can. I did not do the print statement right. That was brain fart. Print out letter. All right, so this does work. You can iterate over these strings. So again, the thing you can only use for to iterate over items in an object. So the string here basically says, the code here basically says, hey, for each of the items in Word, go ahead and print out that item. So I could change the letter to be any variable I want. This construct knows how to take this thing. And again, it's only over things that are iterable. So if I put something in here that was not iterable, like I don't think integers are iterable. So let's say if I put like something like this, and I try to do this, just to show you that this could be anything. And I put number, just so it makes a little more sense to you. For number in Word, go ahead and print number. We print that out, and it tells us immediately, integer, type error, integer, object is not iterable. So pretty much everything in Python is an object. We're gonna learn about objects, but this construct only works for any type of iterable object. What are some iterable objects? Things like list. So let's say my list. Remember, a list is just a collection of things. So you can say my list equals, let's say, maybe it's a shopping list, and we're gonna say apples. And we're gonna say noodles. We wanna make a little spaghetti, but without sauce, because that's weird. Let's say chocolate. And let's do one more thing, and let's say LaCroix. I don't have any tonight. LaCroix, I think that's how you spell it. Is it LaCroix? We're gonna find out right now. We have to make sure we spell it right for that sweet LaCroix sponsorship we're gonna get. LaCroix. Spelled it right. Naturally essence sparkling water. We're gonna give them the whole name here. For anyone who doesn't know, we drink LaCroix on this channel because we're fancy, even though it's not that good. And they're gonna sponsor us because of the amount of sheer screen time it gets. Naturally LaCroix, naturally essenced sparkling water. All right, there we go. So we get some apples, we got some noodles, we got some chocolate, And we have some LaCroix naturally essenced sparkling water in our shopping list. And lists are iterable. So we can say for item in my list. Go ahead and print that item. And hit escape. And let's run this and let's see if we can get our stuff out here. So on our list, we have apples, we have noodles, we have chocolat, and we have LaCroix naturally essence sparkling water. So again, we were able to use the for and the in keyword to iterate over an object here. Over an object here, which is really nice. This construct is really nice. This is not available. This is not available in Go, which is really annoying. I really would like something like this. In fact, I'm going to show you guys how to do that in Go a little bit later, because this is major key right here. I really like it. So you can again use this to iterate over iterable things, which is really nice. And again, you basically know how to do this. You could also actually, let me show you. You can actually do this with a while loop. Let's set up with a while loop too, just so we're getting as much practice as we can. So we want to do the same thing with the while loop. We would say while we would have to set up another counter because again, this doesn't count your iterations. So we set up a counter, so it could just be X. We can say counter equals 0, and we can say while counter is less than length of my list. Go ahead and print item, and we're gonna print this. Item is not defined. Go ahead and print. We can't do that. We need to print out. I lied. This is a indexable thing here. So we actually need to print out. Remember how I talked about how you could use the number here, specify the index like 0. 0 will be the first item, or 1 to be the second item. We can use our counter here to basically iterate on this and print these things out. So we're gonna just say, how do we put this number here? We can actually put counter in here. And then we can add 1 to counter every time. So this will run down the list. I'm gonna show, don't memorize this, it's not important. And so it does print these things out, but look how much harder, look how much more code we had to write using this while loop than we did for these 2 lines for this for loop. And again, this is why understanding which loop to use in each scenario works out really well. It can save you a lot of time. And again, like I said, you can get it done with either loop, but they have their places. Thank you, Hangman's Moose. Thank you for the follow. Welcome to the channel. Yeah. So just wanted to show you I want to show you how different it was. To do that, we actually don't need. Actually, in case we want to come back to this, I'll leave this here. But let's talk about more things you can do with the for loop. Yeah, let's talk about more things we can do with this for loop. So, let's see. I also like Rust. At least what I've seen from Rust. Rust is the next thing I'm going to dive into. I actually don't know. My programming skills aren't Rust worthy yet. I've never been that low level before. And so I'm interested. I want to learn Rust so I can truly understand. I don't know, just get a little bit deeper. I do like Rust so far. Can we get the index 2? What do you mean, can we get the index 2? You mean like print out what the index is? Is that what you're saying? Was that Jack Skili in the for loop? Yes. You can use indexes in the for loop. Maybe I'll show you an example. Actually, I want to see something real quick. Let's actually pull up. Let's go to, again, I don't want you to memorize these things. I want you to understand the concepts of them and know where to go with them. So let's go to W3 Schools really quick. Let's look at let's look at the for loop. Let's see what actually options we have available to us. Again, I want you to know where to go, because remember, W3 School is a great place to find some stuff. Python, for loops. Let's see what options we have available to us. Okay, so this is basically what I did just now. I didn't realize they had a good example here. So they basically did for x in fruits, print this out. So again, these don't matter. Like the for and the in are important. This first item is a variable to represent whatever item you're talking about. And this is the item, this is the object that you want to iterate over. So that's a good thing. We also did a string just like this one. We looped through a string there. That you can use the break in continue things here as well. Range, let's talk about range before I show you some other stuff. So range, remember when we did FizzBuzz and the first thing we had to do was to count to 100. We did not count to 100 in the way that it just shows you with while loops. We use the range function, and the range function returns a sequence of numbers starting from 0 by default in increments by 1. So range is literally a function to make sure you do not have to increment numbers by 1 underneath if that's something that you need to do. So let's start with that. How would we use this? We would still use a variable here. So we would say number in range 100. So we want to go to 100. Let's go for a number in range 100, print number. So again, we have this cool thing available to us called range, which you should know. And it goes ahead and it prints out everything up to 99. Very, very interesting. Why does it only print out 99? Because range is not inclusive of the last number. It ends at a specified number, so it does not include it into the specified number, but it is not inclusive of it. So you would have to go to 101 to do that, and we did that during the we actually did exactly this during the FizzBuzz thing. So yeah, so range is really good. Again, what does range do? Definitely write down range. Range is something you will use in Python. Range is something great that to have available to you in Python. And again, it basically runs through. You can actually specify the starting point. It starts at 0 by default. So let's say I want to start at 5 instead. You can do this. Hello, Timic. Welcome to the channel. Thank you for the follow. And so if you saw here, I put in that first number, 5, it starts at 5. So it starts at whatever you want it to start at, and it goes up to whatever you put in there. And so it starts at 0 by default. So I can do 92, and it'll just print out 92 to 100. And you can see here, it prints out 90 to 100. So range is great. Again, it just adds 1. It's a simple function. We could write the range function ourselves, or you could just use it, which is super nice. So you can use that to count to 100. You could also use that because it's a number. I could also use it to let's say print out my list. And because it's a number there, I could put number in here, and I could use that as the index for my list. But let's see what happens when we do this. We run it, we get apples, we get noodles, we get chocolate, we get LaCroix, naturally essence sparkling water, and then we get this error, which is list index out of range. And why does that happen? That happens because we tried to specify more indexes than are available here. Although there are, the only indexes here are 0, 1, 2, and 3, only goes up to 3. So as soon as this range gets to 4, it fails out. You can only specify, ranges that exist. And so it fails. So you can use this to specify an index number here. So yeah. Do you solve leak code problems? Yeah. We'll do some leak code problems on here. And maybe that's what so we're going to be doing some exorcism.io stuff on Wednesday. Yes, on Wednesday. But yeah, we'll get into some leak code problems. They're all, the way that you approach solving them is very similar. and they're very similar. So we can definitely do some LeetCode problems one day. Right tonight we will not. We're still picking up the tools that we need to solve these things. Once we get on board with loops, once we get loops under our belt, which we're getting under our belt tonight, and once we get functions under our belt, we'll be able to solve a lot of stuff. Then we'll learn about objects to be able to, like, object-oriented programming to help us solve things a little bit easier. But yeah, we almost have all the tools that we need to solve pretty much any problem that we want to solve. You could probably get through it, brute force some things right now. Now that you know some loops, you could probably get through a ton of things right now. So we can use for in that fashion. Using the range function is commonly used with the range function. What are the options here? So one thing I did not tell you all is that with while loops, this is here as well, but they do use an else statement. You can include an else statement just like an if else statement, and it's something that will happen when the loop has ended. So once you've kind of gotten out of it, it lets you know it's finished. This is not a common paradigm that I see. I've actually never seen anyone use it like in this fashion to like show that the loop is finished. You generally would just put underneath it that you just print the loop is finished. But if you got more stuff happening, I get it. I definitely understand it. But I generally don't see that done. But it is something you have available to you. And then we'll do a nested loop in a second. But you can put loops inside of loops. The deeper the loop is, that's the one that will basically it'll run the first iteration of the big one, and when it gets here, it'll run all the iterations of this one before going to the next iteration of this one. It is a complicated thing to wrap your head around. I found it complicated the first time someone showed it to me. I was like, man, look, I just barely understand loops. Now you're telling me I can run loops inside of loops? That seems crazy. We're gonna run one of those in a second. Past statement, we learned about that. Interesting. I didn't know that the for loop in Python doesn't accept the same operator as like the JavaScript for loop. Let me see something here. Or like the Go for loop. I thought it did. We can try it in a second. We're looking at JavaScript stuff now, just comparing some things. So a lot of the times with for loops, so a bunch of languages actually have this syntax right here, which is very interesting. It's a for loop, and then you specify an iteration condition, basically a condition in which you want to iterate. And so basically the first thing is you set up your counter, same way we were doing like x equals 1 before the while loop is what this is. Then you set your true or false statement, and then this shows what to do at the end of every loop so that you don't have to manually have to add one. You can specify it up here, and then it'll go through and run. But that's interesting. I think I knew Python didn't have that, but I think every time I realize it doesn't have that, it surprises me of how simple Python is. I kind of like it. I kind of like that a lot. All right. Cool. Let's do some more for loop stuff, and then let's do some nested loops. So let's do this. Let's say, so let's change this really quick to shopping lists. That's why for loops are infinitely better. I agree for loops are, I don't use while loops. I agree that for loops are infinitely better, but I don't know. I mean, I need to start doing more stuff with Python again. I feel like I would be limited. I'm trying to think through I'm randomly just trying to think through some situations right now. Between the JavaScript and the go for loop, like I'm trying to think if I would be lost not being able to set up this iteration condition like this, like not this exact syntax, but like it would be great to be able to do that in line. But yeah, all right, we can mess around with that. I'm sure I can set that up, just not in line like that. So let's call this shopping list, and then let's start a new line, and let's call this adjectives. So we're going to describe the things on our shopping list. So we're going to say apples, they're red. We're going to say This is dumb, but we're gonna say apples are red. We're gonna say noodles are long. We're gonna say chocolate is melty. Not a real adjective, but and LaCroix is static. TV static to be. There we go. TV static. All right, so we have another list here. You would never. This is again a dumb example. All of our examples are just for fun. So we're gonna say for item in shopping list, we're gonna go ahead and print out the shopping list item. So this is gonna put us back in a place where we can print out everything on our shopping list. Let's save it. Let's run it to make sure we're printing out everything on our shopping list. Item in shopping list. Print out shopping list. What am I doing here? What was my error? List indices must be integers, not slices. Oh, never mind. I don't need to do that. I just need to print item. Yep. Just print item. Cool. So we're gonna print out these items. Whack. This is not. I'm gonna do this with the nest. I'm gonna do this with the nested while loop in a second. This is not gonna show the thing that I wanted it to show, but it's fine. So right now it prints this out. We could put another list in here, and we could have it print out every adjective for every item in this list. So instead of printing out the item, we're gonna say we're gonna put another list in here, and we're gonna say for adjective in adjectives. Go ahead and print out. Let's do an F print format statement. We're gonna say item. So whatever item we're on in the top list, item is adjective. All right, I know this is confusing. We're gonna run this and we are going to see what happens. Oh, I did not close the string here. Okay, let's take a look at what happened and introduce you to the weird world, which is nested loops. It's something that can be very problematic to get through. They're great for brute forcing problems, but they're easy to run into problems with. So what do we have here? We says apples is red, apples is long, apples is melty, apples is TV static. Then we get noodles is red, noodles is long, noodles is melty, noodles is a TV static. Chocolate is red, chocolate is long, chocolate is melty, chocolate is TV static. LaCroix naturally essenced sparkling water is red. LaCroix naturally essenced sparkling water is long. LaCroix naturally essenced sparkling water is melty. And LaCroix naturally essenced sparkling water is TV static. So it looks like we got every item in our list to basically print out a sentence with every single adjective here. So let's mentally walk our way through how nested loops work. So what happens on the first run here? So we say for item in shopping list. So it's going to grab the first item out of shopping list, and it's going to go ahead and it's going to use that item. What's the first item in shopping list? It is apples. So apples goes through and it says, it uses that, but it automatically hits another for loop. It immediately hits another for loop, and it says for adjectives and adjectives, adjective and adjectives. So it's gonna choose the first item out of adjectives, and it's gonna go ahead and print this statement. It's gonna print the item that was specified here, and then it's gonna print the adjective. So it's gonna say apples is red. Now, because this for loop is the one that it's nested in, it's going to go ahead and it's going to run through all iterations of this before looping back outwards to this one. So now it has to go through everything in adjectives. So it prints apple is red, Now it goes through, it loops again, it goes to the next adjective. This apple is now long. Apple is now melty. Apple is now TV static. So it loops through all of these things. And then once it's done doing all that, it exits this. So now this next loop can start over. So the next item here is now noodles. And so now noodles is now the item that's in this one. So the adjectives start all over again. So noodles is red. Noodles is long, noodles is melty, noodles is TV static. Drop back out, loop back over. Chocolate is red, chocolate's long, chocolate's melty, chocolate's TV static, and so on. I'm not gonna say LaCroix naturally essence sparkling water, even though I spelled naturally essence strong. I'm not gonna say that many times. Again, I'm actually really tired of saying it, even though I should go get some more LaCroix. But you can see here, it goes through every single adjective for a single item first, then it moves on to a new item, does it all again. So again, nested loops work that way. We can make this infinitely longer by like doing something like I'm really making up stuff. Another opinion. I mean, we're just gonna say our opinion of them is gonna say good and comma bad, and we're gonna go ahead and do another loop. So you can always keep nesting these loops, but the more and more you nest loops, it gets really annoying. So we're gonna go ahead and put another loop in here for for opinion, and I'm gonna fix opinions in opinions. I spelled that wrong up top. Now we're gonna go ahead and print out this. Item is adjective, and I think it is opinion. Let's go ahead and fix opinion over here. All right, so we now have three nested for loops. Really interesting. This is something you shouldn't do unless you absolutely have to. And so now let's just see the output here. And we do it here and we say, apples is red and I think it is good. Apples is red and I think it is bad. And it goes through, and again, you can see here how it loops through. It does both. It does all the options that are in the loop that is most that is deepest in the nest, the one that is most nested. It runs through all those options first before working backwards. So you can see here, it keeps red. So apples goes from here all the way to here. So we have a bunch of iterations of apples, but we only have 2 iterations of red because we only have a good and a bad here. So each of these is a single time. This is doubled up, and there are a bunch of these because again, that deepest loop takes place first, reaches out to the outside, keeps going. So nested loops can be super duper annoying. We can use these sweet nested loops to sing songs like 99 bottles of beer on the wall song and all kinds of stuff like that. So cool. That's a really, I don't know. So yes, nested loops are pretty fun there, but annoying to debug. Don't do any of this. All right, so I'm trying to think here of, we already did FizzBuzz. I'm trying to think of some other good, I'm trying to think of another good, like, common coding problem that we would need to loop. We would need to use either one of these loops. So let's actually just do a problem. Let's do a problem. Let's go to, what was that? What was the site that we were on before? We were on Python, problems, Python. We were on a site that I shared. It's like Python problems.org. This can't be it. Does anyone have that link? That had a really good simple problems. I don't want to hop into something super hard. Python. It wasn't problems. It was Python. You know what? Let's see. What's that? Practice Python. There we go. PracticePython.org. Let's see if there's a good one on here. Let's see if we can use one of these loops to do this. So we did Lists less than 10. All right, so this is actually great. We actually never did this one. And actually I think this one did not have a solution maybe. Cool. All right, let's do this one real quick. This is exciting. Let's take this. Let's read it real quick. So we're gonna take this list. Thank you, Ari Winokur, and F Momo for finding that for me. I should have had it saved somewhere. But let's take a list. Say, for example, this one. They give us a list here. So you can also take this and copy and paste. Let's copy and paste into a file here. We're going to write a program that prints out all the elements of the list that are less than 5. So it's only going to print out the things that are less than 5. And then we'll look at the extras in a little bit. Let's copy exactly this so that we know what's going on. Vim practice.py. We'll paste this bad boy in here. So I like to paste it at the top just so everyone knows what we're working on at the time. And very, very simply, what are we going to do? You're going to write this program that prints out all the elements in the list that are less than 5. So what can we do to do this first? First, maybe to start a problem like this, maybe I want to first figure out how to print all the elements. Like maybe that's the first thing that I want to do before I introduce any logic. So how do we print all the elements? We just learned 2 different types of loops. Take a minute to think about which loop would be best for us wanting to print out all the elements in this list. We learned the caveats of a while. We have a for loop available to us. We have a while loop. Which one do we think is better for our scenario? Ooh. Let's see what's happening. Yes. Okay. Sorry. I fixed something that I was working on and I was waiting for it to finish. Extra point for one-line list comprehensions. All right, we will do that. I like that. I like that. We'll do a list comprehension. I don't think we've actually talked about list comprehension yet. Okay, so the thing that we want to use, here is we actually want to use a for loop. Yes, we know that a list is iterable, so we can use a for loop to print these things out. So we can say, first we need to copy and paste this line right here. All right, so we got A here. We have our list here, which is called A. And we want to print out everything that's in A. So we're going to say for item in A. And again, this first thing, remember, it could be literally anything. I like to make it something kind of descriptive. That's something that's going on. Item is usually a safe one. So for item in A, go ahead and print item. So for each item, so basically you can read that as for each item that is in A, A is here. So for each of the items that it's in here, go ahead and print what that item is. So let's go ahead and run that and make sure that we've done this properly. Python3 practice.py. So 1, 1, 2, 3, 5, 8, 13, 21, 34, 55. 89. So we have 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89. It felt this, I don't know if those numbers are the same, but it felt the same saying it. That is a common way that I use, a common, very inefficient way to determine if a number I just looked at is the same as another number that I need to check it against. You say it again, and if it feels right, it probably is right. So trust your heart. Don't do that, but it does, it works for me most of the time. Definitely works for me most of the time. All right, so we got to print those things out. So write a program that prints out all the elements in the list that are less than 5. So now we can go ahead and we can use, we can simply add in this logic now, so we know how to compare things to make sure they are less than 5. So we can say if that item is less than 5, we'll go ahead and print that bad boy out to the screen. But besides that, we don't really need to do anything. So we don't really need to add an else. We don't really need to do anything. Then we can just stop there. So let's see if that does that. We run it, we get 1, 2, and we get 3. We know the other numbers in the list are 5, 8, 13, 21, 34, 55, 89. But we only wanted to print things that were less than 5. 5 did not print. Is 5 less than 5? No, it is not. It is equal to 5. So it looks like we've achieved what we want to achieve. I like what EC Goodness put in the chat. Someone else talked about it before for extra points for one line list comprehensions. You can do this in a single line. You can say, I'm going to copy exactly what you put here. And let's print this in and take a look at what it is. So this we can wait. I'm gonna get the muscle memory down. I know sometimes you guys are like, what's taking them so long to do this stuff? I'm really, all the stuff that I suck at in Vim, I'm really trying to get the muscle memory down for it. So like block commenting, I know there's a better way in Nerd Tree, but I really like practicing the way that I learned. We don't do this one. I really like doing that. It makes me feel really cool. But I always have to think about it before I do it. It's not muscle memory yet at all. So I'm gonna take it. I'm gonna take it as you sent it, and we're gonna go ahead and we're gonna run this. And when we do that, nothing happens. Why does nothing happen here? Let's look at list comprehensions so that you know what it is. List comprehensions is a way to basically inline. It's a way for you to kind of inline, do like process things on a list. You can make modifications to those items. But let's look up list comprehensions really quick. So I'm not just doing something without you having any context. Actually, I like to keep using W3 Schools, not because I think it's the best resource for Python, but it's the way that it explains things, it's pretty consistent. So we'll see if they have it on here. W3 Schools comprehension. They probably do, but it probably is not spoken about as. Let's loop through at item. Let's search. Nope. Let's Google list comprehension so that you can have a resource to refer to. Oh, I'm going to do it, but I want you to have a resource to refer to. Python list. I don't know if this is a good resource. I'm going to share it because, yes, 100%. I did not assign a value to it, and I didn't actually print it. But I want people to understand what we're doing here, and this is actually more words than I wanted, but that's fine. But it says here, list comprehensions are a way to provide a concise way to create lists. Yeah, so it's some syntactic sugar to be able to create lists accordingly. It consists of brackets containing an expression followed by a for clause. So we can see here, let's look at ours to make sure we are following the same things here. So we have a for clause in here, and it is in fact inside of brackets containing an expression, just like they say here. Then 0 or more for or if clauses. The expression can be anything. So again, this is just a concise way to be able to do this, but you do have to, again, UC Goodness shouted it out, but you have to assign it to, you have to assign that evaluation to something over here to give it a new list. Like you're basically creating a new list. You can assign it to the same thing, but we have A here, and we can assign this to new A, or we can assign it back to A. But we're gonna say new A equals, and then we're gonna print that. We're gonna print that list. So it actually puts it in a list. So before we're printing things out, we actually weren't creating a new list. But here we are creating a new list. So we're gonna print out new A. And let's take a look at that. So it says I for I in A. So I could use item instead of I, but again, for I in A, if I is less than 5. So let's see what happens when we print this. And instead, so before we had this, and now we return a list comprehension here, and we did a list comprehension, and we return the value of that new list that it created, which has the values which would have been printed 1, 1, 2, and 3. And there's list comprehensions are great. They're best to use if you want to use that, again, if you want to create a new list, and you want to be able to use that data elsewhere, you can do that. List comprehensions are great for that. You could also, this will be dumb, but you could also, for item in new A, if you wanted the same output, you can do for item in new A. You could print the item, which is dumb. This will be weird, but you could get the same output with the same thing, the same output that we got above. But again, if we wanted to use the data that was available to us, if we wanted to use all the numbers that were less than 5, we could use this list comprehension here to easily grab them for sure and print those things out. So that is list comprehension. Again, an easy, concise way to do things inline. I would check out list comprehensions. I don't think it's one of the last things that I would spend time trying to get good at while you're learning all the other things. Like if you're just getting the loops and like this is new to you, like I would focus on those things. And when we get to functions, focus on those things and learn about scope. Before you try to get good at list comprehensions, you can build these lists in other ways. You know how to use the append functions, etc. But I do really like list comprehensions. They do make your life a lot easier, for sure. I was trying to stay away from it in the beginning, and I have to catch myself not immediately just writing one, because like it is, I find, even though they are easy for you after you kind of have a good understanding of them, I think it's a little confusing when you are first learning. Doing simple common operations, they really are. They are super great for that. I remember the first time I really understood what a list comprehension was, and I was doing some algorithm problem. I actually think I was doing it for that's actually how I found out about list comprehensions. I never ran across them when I was first learning how to code, because I'm mostly self-taught. And I did a coding interview, and I did a take-home test, and we took it in. I was meeting with the company, and we were going over what I had done, and they were like, yeah, like this is the logic. Your logic is perfect, spot on. You figure out how to solve the problem. They're like, but you can make this a little bit cleaner if you just did this. And when they did it, I was like, first off, that's magic, and 2, how come no one told me about this? And then like cleaned up, it dropped my code. Like they removed 35 lines of code from my thing, which was great, just using random list comprehensions, not random, but good list comprehensions. And so that was interesting. It was a good learning experience. But it did take me, it took me a surprising amount to be able to use them right. I don't know why. I think it was just new syntax, and I had been doing things the old way. And I think because I was still learning so much, it was tough. Yeah. One dictionary comprehension that we used a few times. So yes, swap keys and values. I actually have found myself needing to use dictionary comprehensions more than I've used list comprehensions, to be honest. I think because I think I overused. I think there are better ways to solve some problems that I brute force through using dictionaries. And dictionary comprehensions have been there to kind of save me and keep me going when maybe I should use something else. But yeah, they're pretty nice. Cool. So we're able to solve that problem. Let's look at the extras. Let's look at the extras that are available for this, because we were able to do that one pretty fast. I thought those would be a little harder. So instead of printing the elements one by one, oh, well, it says it right here. So this is where list comprehension would have been amazing. So instead of printing out elements one by one, which we did originally, make a new list. So that's what we did with list comprehension. We created a brand new list of elements less than 5 from this. What? Hold on. Make a new list that has all the elements less than 5, so everything less than 5 from this list, and print it out in this new list. Print out this new list. So that's what we did originally. That's what we have. I think that's what we have right now. That's what this is. So we already did our extra number 1 thing here. That's cool. So number 2, write this in 1 line of Python. So cool. Let's go ahead and write this in 1 line of Python. So they basically want us to print this out. So let's do a little, if you were doing this yourself, what would you do? You would say, okay, Google, what would you Google here? Maybe the first time, I'm trying to think of what I would, like, without Googling the exact thing. Like, let's say, how do I write everything on 1 line in Python? Maybe I would write something like this. Maybe I would do something like this. And I look through and I see here, and I'm like, I don't know. Oh, look at this. Unfortunately, it's not possible. Python makes close useless command 1 line programs, even if explicit parentheses. Looks like you can do a sequence of them by using semicolons. And looks like they do a for loop here, which we kind of do with our list comprehension. And they do a colon, they just print this out. They do a semicolon and they print. So let's just try something. Let's try it out now. I don't know. They want us to assign it to the new list and do it all together. Let's see if that even works. So maybe let's try the colon first. And what did it say? Print new A. This seems like it's not going to work. Well, let's try it out and let's have a little bit of fun. Again, you want to practice. We'll print invalid syntax. Didn't work. Oh, wait, never mind. I did this twice. Let's remove this. Now let's try it. And error, invalid syntax, right where we put it. So we were looking at that example. It says also, let's see if we can do a semicolon, and let's see if that works. And look at that works. So you can chain together these statements in Python. Yeah, like that, to put it on 1 line. You could also probably do, I think somebody said it actually. Yes, Easy Goodness did say it. You could also probably put a print statement around the whole thing. And this will probably work. And you cannot, but I think you could do it around actually, what was the error, just to make sure? New A is an invalid keyword argument for print, so I guess you can't do that. I thought that would work too, but maybe, I wonder if you could put it around just the list comprehension itself. That would be interesting. I don't know why you would want to do it like this. I don't even know if you can. Let's find out. And this works as well. That works as well. You could put it right around the list comprehension. So that's another way to 1-line it. So again, we learned a couple different things here. We learned that you could put the print around the evaluation itself, or we could use our trusty dusty semicolon to indicate that the next line is here. And we could also print out new A. So fun there. Both of those things work. Oh, it needs to be the walrus operator. Okay, we're gonna do walrus operator. Oh yeah, okay, I see here. Sure, we'll just do it right now. Interesting. I wonder. That's very interesting. So if you do, you're saying if you do a print, F close this, and you simply walrus it. I simply walrus it. It'll work. I like walruses. Aha, nice, cool. That's good. That's good to know. So you can do the whole thing with the walrus operator. That's it makes sense. I think that's why I thought it could work. Because I think this will work. I think I've done this in Python. I mean, in Go, and I think I assume this would work. But this makes even more sense using the walrus operator, which is nice. Yeah, and I am running 3.8, so that's good. Google, how do I DevOps Python like a pro? You could do that if you wanted. Wouldn't give you back any real information. You'll be surprised about how. So anyone coming from the DevOps side of things who's trying to learn, anyone who's taking the DevOps course who's also just trying to pick up a programming language like Python, these base tools are really all you need. You don't need much more. You don't need much more than these base tools, which is really nice. You can get so much done with, again, you can write some loops, you can set some variables, you can do some, conditional statements. You can do a lot of automation. You probably have to learn a little bit about how to like do some OS commands and like manage some system files and stuff, maybe. But there's plenty of ways to get through all of that. What's up, Sarcasm as a Service? I love it. I like that name a lot. Welcome. Thank you for the follow. Welcome to the channel. Cool. So walrus operator, we learned a lot just now. We did the assignment operator as part of expression with the walrus. We learned that we could combine commands kind of in one line using a semicolon. We learned that you can do list comprehensions on a list. You can more concisely create a new list using a list comprehension, which we did here. Cool. And what was the third? Let's check out what the third item here was. There was one more thing. Ask the user for a number and return a list that contains only elements from the original list A that are smaller than the number given by the user. So one last thing, we want to ask the user for input. We want to ask the user for a number, and we want to return a list that only contains elements from the original list. That list was called A, that are smaller than the number given by the user. So I don't know why that sounds so wordy for a simple problem. But the first thing we want to do is we want to ask the user for a number. What's up, Pop Logics? I like that. Welcome to the channel. Thank you for the follow. Let's go ahead and ask the user for some input. So we're just going to call this user input. We're set that equal to. How do we ask the user for input? That is the input function. I'm going to say, come on, give us a number. Give us a number. And so that's not a question, even though we're asking for it. We're making a demand of our user. Now, so that's gonna go ahead and have them give us a number. So let's check and make sure that works first. Come on, give us a number. We're gonna say 67. And it goes through and it still prints out the same thing we were seeing before. So we got a number. We can confirm that we can ask for a number. We don't know if it's doing anything. We can ask for it. Now, for what the problem asks us, it wants us to return a list. So this is, again, using that list comprehension. We need to create a list. List comprehension is a great way to do this very concisely without having to create a list and append things to it. This is great. So we want to create a list that only elements from the original list A that are smaller than the number given by the user. So we want to check only for numbers that are smaller than the number given by user. The number that was given by the user is assigned to user input. So we can use our list comprehension that we have available to us, and we can check if the number that we are, this statement is iterating through this list right here. So we can check if the item that it's on is less than user input. And actually, let's put some space in here. Is it going to work if All right, so now instead of checking if I is less than 5, it's going to check if I is less than user input. So let's test this out a bit. It's checking to only return numbers that are less than the number we pass in. So let's first, let's go ahead and cat this file so you can see the numbers that are here. So we know we have 1 through 1, 2, 3. Our lowest number is 1, our highest number is 89. So let's go ahead and run it. And let's start with passing in 1. And that will fail. Not supported between instances of int and string. Why is that happening? Let's take a look. And we got an error here. It looks like the less than does not work between an int and a string. So it sounds like we have something here that is a string. So what's a string? Whoops. Bam. So what's a string? We know that user input always returns a string unless otherwise specified. So we can do, we'll do it here. We'll typecast it here and we'll say string. We will typecast it to a string here. And now we will do it again. See what our numbers are. Run it. We're gonna enter in 1. Not that, 1. And that's, wow, that was dumb. That was really dumb. It's already a string. That's a brain fart. That's a late night brain fart. It's already a string. We don't want it to be a string. We want it to be an int. So also important to note, you see me make little problems like that all the time when I'm rushing. When you're first learning, it can be it can take you a long time to find that you made a problem like that. I'll usually find them pretty quick. Just because I make them so often and like I know what to look for. But in the beginning, it can send you down a long rabbit hole when doing that. So don't rush through things. Don't rush through things. I should stop rushing through things, but I'm trying to get you all out of here in the next couple minutes. I think we're done with this right now. But it's okay to make mistakes. Just do your best to really comb over what you've already done, because a lot of times you'll do things like that. Like I originally said that we needed to cast this to something else, knowing that there was a mismatch. We knew it was supposed to be an integer, but we kept saying string, or I kept saying string. So just, I don't know, just something to be cognizant of. So take our number, let's put in 1 again, and it returns us back a list. So we know that a list is denoted by open close brackets. When you see brackets, you should think list. And we can see here, we actually got back, it worked. We didn't get back any numbers, but we were able to get back an empty bracket. That's because nothing in this list is less than 1. So let's go ahead and let's go ahead and do 2. And if we do 2, we only get 1 because only 1 is less than 2. So it does look like it's working. Let's do it again. Let's do like 68. And we hit enter, and all these numbers, in fact, are less than 68, but there are numbers, or there is a number in here that is more, and it did not get returned, so that is excellent. So let's see if we can get back the whole entire list. Let's do a number like 100, and it goes ahead and it gives us back the whole entire list. So just like that, we were able to combine, again, some of the tools, not even some of the tools, a lot of the tools that we've learned to be able to do this in a pretty concise way. We were able to grab user input. We were able to display user output. We were able to iterate over an object, over an item. We iterated over a list using a for loop. We actually did some list comprehension here. And we were able to do some comparison here to make sure we got back what we wanted. Here's why list comprehensions are great really quick. Actually, I just want to show you what this looks like without a list comprehension. If we want a new list, we have to specify a new list. So we have to say something like new A equals something like this. So this is probably how you would write it if we didn't just go over that. You would do new list equals A, start a new list, and then you would say for item in A, or we used I below, so just to make it a little more understandable, we'll do for I in A. We want to say if I is less than user input, go ahead and new a dot append I. And then at the very end, we want to print print new A. All right, so this is something we did in one line. This is what we did in one line. This is what it would look like outside. And let's run it just to make sure it works. And we can just look at it really quick. So have a number. Let's do 100, and we get all of our stuff in here. So this looks just like this. Let's use the same numbers. Let's do 68. And 68 gives us the same output. And 2 gives us the same output. So, yeah, if you're not going to use a list comprehension, you have to basically create a new list, and you have to use the append function. We learned about the append method to be able to add these things to the list. So every time it hits the append, it'll add this item into here, and it'll just keep adding on as we get through based on this information. So just a few different ways to do things. It took all these lines to do the same thing that this one line did. So don't spend a lot of time in the beginning, again, learning how to optimize it for this one line standard, but do check it out this way. Well, this is I just want to show you what it would look like, kind of just raw, like, yeah, just raw. So cool. Yo, Brian, what's up, man? Unbelievable. So everyone, this is great. Unbelievable is someone I used to work with. He's a super dope dev. And when you guys see, like, I'm on line 6 right now. When you see those things change colors, there's a Vim plugin called Quickscope, and I'm actually going to tell the Prime again about this because I think he would like it because he's a super duper Vim user. But you can see here how the A changes color, the I changes color. In Vim, you can use there's a F operator here, an F command that you can use to traverse horizontally on the line. So let's say I'm on this line here, and my cursor is over here to the left, and I want to get I'm trying to like mess with something over here. I can hit F, and then I can hit a letter, and this shows like the first iteration of these letters. And so I could hit F, and then I could hit B, and it will take my cursor all the way over to the B, which is super nice. This is something that works no matter what. You don't need the plugin. You don't need this plugin to use it, but it highlights these things for you so you can easily see. Yeah. No. You need the plug, but I still use it because it's really good. So it's really nice. It's good for traversal. Horizontally, it's really great. It's a really good plugin. I'll link it in a second, or you can link it if you want. But shameless plug there for that. But good to see you, man. I'm glad you're on taking a look. We're actually wrapping up right now, though. But cool. How are things in your new life? Very interesting. I'm really happy you hopped on, man. Duke Nukem, today we were just learning about loops in Python. So for loops and while loops in Python. So we're just going to start to learn how to use these things to start solving some problems. We're going to spend the first like 45 minutes learning about Git on Wednesday, and then we're just going to solve problems. And we're going to be pushing those things up to Git. So we're going to be using the stuff a lot. Python, the name is thrown about, but does anyone know what it really is? What exactly is Python, the name? So Python is actually, so the icon's a snake. I don't think we were talking about it, but it has nothing to do with the snake Python. It has everything to do with the movies, the Monty Python series, and that's why the creator did it. It's actually a bunch of references in the documentation and stuff to things that happen in the movies, which is pretty interesting. A lot of people don't know that, but yeah. We'll catch up. Yeah, for sure. We still got to do Korean barbecue, man. It still didn't open. We can go somewhere else though. We can go hit Iron Age or something. But next time you're around. I also need to come to New York, man. I gotta find some time. Maybe when this round of streams is over, I'll come through, because I have so many people in New York that I need to come see. I have so many friends that moved up there that I haven't seen in a while, and I feel like a bad friend, even though New York's only a few hours away. So I'll definitely find some time to get up there, man. But cool. That's it for tonight. I can't stick around for too long for a bunch of questions. So if you have any, throw them out right now. But if not, I hope, again, let's tangible takeaways again. What should you have learned tonight, or what if you didn't get it, what can you go back and search a little more on? So we learned about loops. We learned about what loops are. We learned that they're used to run a set of instructions multiple times. We learned that there are two types of loops in Python. There's the for loop and there's the while loop, and they are generally used for different things. You can use them both to solve the same problem, but they're used for different things. While loops are generally used when you do not know how many times, you're unsure of how many times you need to iterate through something. While loops are easily used to create infinite loops, and you can use operators like the break statement or the continue statement to control the flow of those, or the pass statement to work on the flow of those. Again, break will end all the loop iterations. Continue will only end the current iteration of the loop and move on to the next iteration. And pass will just kind of kick through and keep continuing. Then we learn about for loops, which are similar, but they're best to use when you know how many iterations you need to loop through, or you need to iterate through an object. Again, an iterable object in Python. We haven't talked about objects yet, but things like strings, things like lists are things that you can iterate through, and to just traverse through to be able to take action accordingly. So that is although loops are, we also learned about list comprehensions, which is good. A little bit about list comprehensions, which is good. You saw how to do things two different ways. We learned that this line right here does the same thing as all of this code right here. So check out list comprehensions. Don't stress it if you don't really understand or can't or aren't good at it immediately. Focus on the kind of main concepts first, and you can apply those again to these things later on. Yeah, and I think that's everything. So take some time. You learn about nested loops as well. You learn that the loop that's deepest in the list will run through all of its iterations first, and then it'll work outwards. So it'll really work from right to left in terms of nested loops. So those are fun to play with. So I would take some time, mess with them. They can cause a lot of problems, but they're fun to mess with and to kind of take time to understand. So loops, high level, not an incredibly difficult thing to understand, but it is difficult to learn how to use them effectively and to like wrap your head around following the logic for a loop. So play with them. Do your best to play with them. You're going to use a loop to solve almost every single algorithmic problem we go through. You're going to use some type of loop to solve it in one way or another. So just practice them. Try to just get familiar with them. Even if you don't truly understand them, just see if you can, just see how much you can gather about it before Wednesday, when we're going to run through some more stuff and actually do some more problems. But you almost have all the tools under your tool belt. We really are really close to having all the tools. I would really even say after next Monday, you'll have all the tools. After we grab functions, you really have all the tools. Again, object-oriented programming is big in something like Python, and it does help a lot of things, but you're going to be able to you're going to have the base level of tools without learning how to use classes, to be 100% honest, and really understanding object-oriented programming. But you're not going to be able to do any of the cool projects we're going to do until we do understand those things. So that's going to be exciting. Where are you from anyway? I am from right outside of DC. I'm from Prince George's County. Currently I'm in Baltimore, Maryland. That's where I live. That's where I work currently. But I'm from right outside of DC. Yep. Acela from DC to New York. Yeah, for the win. The Acela is pretty nice. The train's pretty expensive. Like I have a car that's pretty fuel efficient. So like a drive up to New York is nothing. I got to worry about parking, but like, and tolls are crazy. Tolls are crazy on the way up to New York from Maryland, but it can be a lot cheaper, but the train is just so much nicer. You can just sit and chill, and there's Wi-Fi on there now. You get your headphones, and it's super nice. You play some games if you got a Switch or something. But yeah, I'm definitely gonna make my way up that way. But cool, that's everything for tonight. We have, just to take a look for everyone who wasn't around at the beginning tonight. Wow, why is everything so small? Intro to programming, we have Git, fun with Git. We're getting good at version control and doing some coding challenges on exorcism.io on Wednesday. So hopefully you'll be around for that. And if you're in the DevOps course tomorrow, what do we have tomorrow in DevOps? We just did this. Oh, checkpoint lab. So we have a whole lab tomorrow. I forgot about this. We're basically going to take everything that we've learned up until now, and we're going to try to apply it in kind of a real world thing, real world lab. So things like we learned a little bit about programming. So maybe we'll have a little Go app. And we will, use our sweet Linux skills and our bash scripting skills to set up some stuff and get some stuff installed. And we learned all about load balancers and web traffic management. So web servers and things like that. We're going to be putting all that stuff together. Again, it wasn't a ton of stuff, but it's enough concepts to kind of stop and build something real world with it. So that should be kind of exciting. So if you're interested in that, we do have a lab tomorrow in the DevOps course. And then we're gonna be hopping into the cloud starting next week. Vim link for plugin. Yeah, cool. Let's find that right now. Let's see, GitHub. And let's grab your name. You guys can all go follow user unbelievable. Now everyone knows your name. I'm sorry, I didn't mean to. There he goes, right here. He's famous now, even though we're not famous. But Quickscope is right here. It's got a lot of stars. If you haven't, you're learning about GitHub next time. 511 stars is a lot of stars. So everyone go give it some stars whenever we start GitHub. That's a lot of stars. Whoops, that's not what I meant to do. I meant to take the link and paste that. So there's a link to the Quickscope Vim plugin. If anyone grabs my Vim settings, we do bang Vim settings. It should give you access to my Vimrc, which is, wow, that did not link properly, but okay, I'll fix that. But yeah, it's a cool Vim plugin here, which is dope. So give it a star. I give it another star. Yeah, there you go. You get some stars now. You have 33 forks. That's really good, man. I'm impressed. You got some issues. How old are these? Okay, we got 2 from 2019, 1 from 2017. Are you just ignoring people? Oh, you got some, man, this is great. It's cool. Yeah, check it out. Check it out though. Especially if you're messing around with Vim. That's going too far now. All right, sorry. We'll stick here. A lot of people watching, but that's cool. I don't have any projects with that many stars. That's really cool. But cool. All right, everyone have a good night. Who are we raiding tonight? Who's online that we can raid tonight? I have no idea. Peace, man. Thanks for coming through. Good to see you. We definitely got to make sure we get to that to some Korean barbecue, man. Code is free. Bug fix submit pull request. Yeah. And a beer. I like beer. Beer's my favorite. Well, I've been doing pretty good about not drinking too much beer nowadays. Let's see who's on. Discover. None of our normal people are online right now. Does anyone have anyone in particular that they like to get over to? Just getting to the science and tech section now. Got some astronomy stuff going on. Open source programming in C. Tech startup notify.me. This is a startup. That might be cool. I think I've seen them like once. Let's do that. We're gonna head over to this startup. Oh yeah. I've taken us over to Dow before. Yeah, let's go over to Dow. That's fine. Yeah, I'll just send you over to Dow right now. Cool. Let's head over to Dow right. I agree. So it's gonna raid /raid. I need to just copy this. I need to copy my like common people. And he's doing Python. This is perfect. Look at that. It's DOW. Where's he at? He's usually at the top. Oh no, actually he's right here on the left. DOWRIGHT. Oh, WRIGHT. All right, so we're heading over to invalid username. Oh, I have 2 W's. Whoops. I cannot type, man. This guy's not family friendly, but he's cool. It's an interesting watch. Goes over some Python stuff, knows a lot of stuff. Check him out. I'm gonna watch for a little while too. But thank you everyone for the good stream. Everyone have a good night. I will see you all on Wednesday. Cool. Count you down. 10 seconds. 8 seconds. 6, 5, 4, 3, 2, 1. Everybody have a good night. Prime Zone. We'll go to Prime tomorrow, another night. But cool.